Welcome back, everyone. Today we are going to continue looking at factoring. Over the next couple of videos, we are going to be talking about factoring quadratics. Today we are going to look at trinomials. But first, what is a quadratic expression? Well, if you remember, a quadratic expression is a polynomial with a degree of 2. So the standard form of a quadratic is ax squared plus bx plus c, where a, b, and c are numbers, and the only restriction is that a cannot be 0, right? Because if a is 0, then this first term completely goes away. So that is the standard form of a quadratic, and that's what we're going to be looking at over the next couple videos. So if you'll recall, when we were multiplying polynomials together, if I got x plus 3 times x plus 4, so I would double distribute. I would distribute the x from the first term, or from the first binomial, to the entire second binomial. And then I'd also distribute that 3 to the second binomial. And then, if I start distributing, I would get x squared plus 4x plus 3x plus 12. And then if I combine like terms, I would get x squared plus 7x plus 12. Another way that we can multiply these is by using a box. So if I create a box, on the top I'm going to have x and then plus 3. Vertically I'm going to have x plus 4. And then I'm just going to multiply these together. So I've got x times x is x squared, 3 times x is 3x, x times 4 is 4x, 3 times 4 is 12. So if I combine my terms, I'm going to have x squared plus 7x plus 12. This box is going to be very helpful over our next couple of videos. So if you'll look at these, the box is just a way to organize what we did on the left side of the screen. If you look at the left side of the screen, if I start here, x squared plus 7x plus 12, and then I split that middle term, and then I factor by grouping, and then I finish factoring by grouping, I get back to what we started with. So factoring by grouping is going to come into play, and we're going to use a box to help us organize that information. Now, if we look at x plus 3 and x plus 4, x plus 3 times x plus 4, and our product of x squared plus 7x plus 12, what do we notice is going on here? Well, this 12, how can I get 12 with the numbers that were in my original problem? Well, I can take 3 times 4. How do I get this 7 using 3 and 4? 3 plus 4. Now, there is a reason that pattern exists, and it is because this a value right here, this a value is 1. Because the a value is 1, I start to recognize this pattern. This pattern is going to exist when a is not 1, and we'll get into that in our next video. So let's look at what a problem is going to look like. If I want to factor x squared plus bx plus c, notice how everything is positive. So I'm going to use a box to help organize this information. Now, it's going to take a couple tries to get used to using the box, but once that box clicks, these problems are going to go very, very quickly. So I've got x squared plus 9x plus 20. I make my box. In the upper left-hand box goes x squared. In the bottom right-hand goes 20. So I need to find two numbers that multiply together, and I'm going to put this down here, to give me 20x squared. All I did was multiply along that diagonal. And then they need to add to give me that middle term of 9x. So multiply to give me 20x squared. So this is multiply. And they have to add to give me 9x. So this is where those number diamonds are going to come into play. What two numbers multiply to give me 20x squared and add to give me 9x? Well, after some thought, I can come up with those numbers being 4x and 5x, right? Because 4x plus 5x equals 9x, and 4x times 5x gives me 20x squared. So now what I'm going to do in my box is I'm going to undo the multiplication, which means along the rows and the columns, I'm going to factor out a GCF. So look at x squared and 4x. What goes into both of those? X. What about 5x and 20? What goes into both of those? Positive 5. Looking at the columns, what goes into x squared and 5x? X. What goes into 4x and 20? Plus 4. So what I can do then now is double check my work. Let's actually multiply these together. X times x is x squared. 4 times x is 4x. X times 5 is 5x. 4 times 5 is 20. It all checks out. So I know I actually factored out the greatest common factor. So what does x squared plus 9x plus 20 factor into? It factors into x plus 4 times x plus 5. Alright? And then got to make sure from the beginning that there's no GCFs. We are going to talk about how GCFs play into this starting in the next video. So, let's look at number 2. What do you notice is a little bit weird about number 2? Well, it's not in the standard form of a quadratic. So I need to rewrite this so that it's in standard form. From there, I'm going to create my box. Upper left-hand corner, I'm going to put the first term. Bottom right-hand corner, I'm going to put the middle term. The last term. And then those multiply together to give me 9t squared. So I'm looking for two numbers that multiply to give me 9t squared and add to give me that middle term of 10t. So after some thinking, what multiplies to 9 adds to 10? Well, that's 9 and 1. So I've got 9t and t. So now I'm going to factor using greatest common factors on the rows and on the columns. So what goes into t squared and 9t? Well, that's t. What goes into t and 9? Well, that's positive 1. What goes into the column t squared and t? That's t. What goes into 9t and 9? Well, that's positive 9. So my two factors are t plus 1 times t plus 9. And again, the box just takes practice. It really does. It just takes some practice. All right? Let's keep at it. In case, let's say the box is not your thing, and I implore you to keep trying it. But let's say the box is not your thing. So, in this one, I got t squared plus 10t plus 9. We figured out what multiplies to 9t squared and adds to 10t was 9t and t. So I can split my middle term into those and factor by grouping. That's really what we're doing in the box, is just factoring by grouping. So I get t times t plus 9 plus 1 times t plus 9. Those are the same, so I can factor out t plus 9, and I'm left with t plus 1. Notice how those are the same exact thing. Even though they're flipped around, it does not matter with multiplication. All right, let's keep using the box on some new problems. Notice here, we're trying to factor quadratics, x squared minus bx plus c. So we're going to deal with some negatives now. So it's in standard form. That's good. No GCFs. Let's go straight to our box. So I've got x squared and 12. So they need to multiply to give me 12x squared, and they need to add to give me negative 8x. So they need to multiply to give me 12x squared, and they need to add to give me negative 8x. Well, since they multiply to give me a positive, but add to give me a negative, I know that both my numbers are going to be negative. And they are, after careful thought, negative 6x and negative 2x. Excuse me. So, now factor out the GCFs on the rows and the columns. Your first row, x squared and negative 6x, what do they have in common? They have an x. The second row, negative 2x and 12, what do they have in common? Excuse me. Well, the first term is negative, so I have to factor out a negative. And what goes into 2 and 12? 2. Now, in my first row, what goes into x squared and negative 2x? X. What goes into negative 6x and 12? Well, the first thing I see is negative, so I got to pull out a negative. And then into 6 and 12 is 6. So double check here, multiply everything together, make sure it all works. And then you can say that your factors of this polynomial are x minus 2 times x minus 6. We are undoing the multiplication. And 2, it's not in standard form, so I got to rewrite it. And once I rewrite it, I go to my box. W squared goes into the upper left. 28 goes into the bottom right. So they have to multiply to give me 28w squared. And they have to add to give me negative 11w. Well, those pairs of numbers is going to be negative 7w and negative 4w. And when I factor out the GCFs of the rows and the columns, I get w minus 4. And on the columns, I get w minus 7. So the factors of this polynomial are w minus 4 times w minus 7. And I can always double check my work by multiplying those together. Simple as that. We got 2 more examples to knock out. And that is this, the other types of quadratics we could see. We got a mix of positives and negatives here. So the first one's in standard form, so I can go straight to my box. I send x squared to the upper left, negative 15 to the bottom right. So they have to multiply together to give me negative 15x squared. And they have to add together to give me that middle term of 2x. Okay? So what multiplies to negative 15 and adds to 2? Well, that's going to be positive 5, 5x, and negative 3x. If you ever are stumped at this point, you can write out the factors. So for example, what multiplies to negative 15 adds to 2? Well, that's going to be 15 and negative 1, negative 3 and 5, and I can stop there because those 2 things do it. If you need to list out your factors, please, 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 please do that. So now we need to factor out the GCF on the rows, and I'm going to get x minus 3, and the columns, and I'm going to get x plus 5. So our factors are x plus 5 times x minus 3. And last but not least, standard form quadratic. Create a box. R squared in the top left, negative 24 in the bottom right. So they need to multiply together to give me negative 24r squared. And they have to add together to give me negative 2r. So if I list these factors, I'm going to get negative 24 and 1, negative 12 and 2. Next is going to be negative 8 and 3. Then negative 6 and 4. And I see right there, negative 6 plus 4 is negative 2. So I can fill in the rest of my boxes with negative 6r and 4r. And again, I should have mentioned this, but the order does not matter in how you put those upper right and bottom left boxes. So if you factor out GCF, it's going to work either way. So now when I factor out the GCFs of the rows, I get r plus 4. And of the columns, I get r minus 6. So my final answer for those factors of r squared minus 2r minus 24 is r plus 4 times r minus 6. Alrighty, so ladies and gentlemen, you have some you try nows. Oh, I'm sorry, I forgot one more thing. A prime polynomial. One easy idea is a prime polynomial is a polynomial that cannot be factored. Cannot be factored nicely. So for example, if you're using your box and you have 2 things that multiply to 9x squared and add to negative 3x, and you're going through this and you're like, well, the factors of 9 are 9 times 1. Or since it's negative, since they multiply excuse me, gotta fix this, 9x squared negative 3x. Since they have to multiply to a positive and add to a negative, then they're both going to be negative. But if you're going through this and nothing's actually working, then we say that this polynomial is prime because it cannot be factored. So, very rare that I'm going to give you one of those, but it is an option. If the box isn't working, say that your polynomial is prime. All right, so now back to what I was saying. You have a couple you try nows. You got to practice using this box. All right, do those. We'll go over those the next time I see you. As always, be safe, be good, and I'll see you when I see you.